All right, so today we're going to start a kind of more complicated thing we have to do with integration sometime. So to discover that, I'm going to get you all started on this activity, and then I do want you to finish it on your own. It will help you process this a little bit easier. So we've seen that some integrals are easy to solve because they simply reverse the differentiation process. But there are others that do not follow our basic rules. In fact, there are integrals that cannot be solved without technology and others that cannot be solved at all. So let's look at why. All right, so in this set of integrals below, there is one integral that can't be solved by hand. So we're going to find each antiderivative and determine which one can't be solved, and then we'll explain why. So this first one, the integral of cosine of x dx, that's just a basic rule that we've already talked about. That's sine of x plus c. Now the second one, you might think that that would just be sine of x squared plus c, but let's check it and see if that works. So we'll find the derivative, like we think it's sine squared, or sine of x squared. So let's find the derivative of that. So when we did, it would be cosine of x squared, but then we would have to multiply by the derivative of x squared using the chain rule, right? So that 2x isn't there. So this actually matches up with that one. So this one would be the sine of x squared plus c, and this one is not possible. Because it's missing, we'll say missing parts from the chain rule. But the last one includes those parts, so we can do it. All right, so I want you all to pause the video and do as much as you can with 2 through 4. The more you figure this out on your own, I promise the easier it's going to be for you, and this is going to get challenging. So just do your best here. All right, so this should be the answer. So if you haven't done it yet, pause the video. I really want you to do it. So on number 2, the only one that was possible was this one. Because of that chain rule, you would need a 2x that's missing. All right, so let's just write a little note that the derivative of the inside function must be part of the integrand. Oops. All right, now this next one is a little bit more complicated. So I did most of this. So the inside function is going to be x squared minus 2. The derivative of that is 2x. And so we almost have all that in the integrand. We have the x part, but not the 2. And we need the 2x for the chain rule. So we're going to change the integrand a little bit. So we are going to put that 2 in there with the x. But we can't just do that because it changes the value. So what you have to do to counteract it is multiply by a 1/2 on the outside, because that's like multiplying by 1. So the 1/2 times the 2 is 1. Doesn't change the value. It just changes it in a way that we can now find the antiderivative. So that 1/2 is on the outside, and then it's going to be the sine of x squared minus 2 plus c. All right, now there's a process that we're going to use to do these, so you don't always just kind of have to figure it out in your head. We're going to use a process that's called U-Substitution. We're going to spend many days on this because there are definitely different levels of difficulty, but it is an extremely important process for the rest of the year. So what we're going to do first on U-Substitution is set U equal to the inner function. Now, people are like, how do I know when I need to do U-Substitution? Well, whenever it's just an x there, you don't have to do it. Whenever there is a function there that the derivative is just 1, you don't have to do it. But if it's an expression where there's an inner function that's squared or multiplied by something, then you are going to need to do U-Substitution. All right. Then the second step, we're going to find du dx, which is the derivative of u with respect to x, and then solve for du. All right, so let's do these steps as we write them. So looking at number 1, the first thing you would do is figure out what the inner function is. So the inner function is going to be the 3x minus 4. Right? And then du dx is the derivative of that. So that's going to be 3. And then to solve for du, we're just going to multiply by that dx. All right. All right, and then for step 3, you're going to do what I call correct the integrand so it matches exactly. Now, your correction can only be multiplying by a constant. You can't multiply by x here. Okay. So now, let's do our correction. So we need a 3 in there. We have the dx, but we don't have the 3. So just like we did on the last one, we'll multiply by that 3. But then to counteract that, on the outside, we need that 1/3. All right, then your next step, let me change colors. You're going to rewrite the entire integral in terms of u. All right, so I'm still going to have that 1/3 out there. But in the place of 3x minus 4, I'm going to replace that with u because that is what it equals. So we would have u to the 5th. All right, and then in the place of 3dx, I'm going to replace that with what it equals, which is du. All right, the next step is to find the antiderivative. Okay, so that 1/3 is going to hang out. All right, we're going to add 1 to the power and divide by the new power. And then plus c. All right, and then our final step. Now this is indefinite integrals. So for indefinite, because there's no upper and lower limits, we're going to plug in the expression for u. Now, if it was definite integral, we do something different. But this one, we don't. All right, so let's go over here. All right, so I'm going to just kind of combine this 1/3 and the 1/6 on the bottom and make that 1/18 out there. Hope that's okay. All right, and then we have u to the 6th. So we're going to replace u with what it equals, which is 3x minus 4 to the 6th, and then plus c. And that should be your answer. I can't get my 1/18 to write. There we go. Right, that is U-substitution. All right, so let's do that with another problem. Okay, so for number 2, first we have to figure out what the inner function is, and we're going to call it u. So I'm going to move over to the side because I have big margins here. So we're going to say u is 7x. All right, then we'll find the derivative of that and solve that for du by multiplying by dx. Okay. All right, now that 7 dx needs to be in my integral, and it isn't. So what I'm going to do is I'm just going to rewrite it. There it is. But that can't just appear out of nowhere, so I have to counteract it by multiplying by 1/7. Okay, then I'm ready to replace all of my 7 x's with u's. And then my 7 dx with du. So after you do that step, you should have no x's left. You only have u's. Okay. Now I'm going to find the antiderivative, so that should be the secant of u plus c. And then my last step is to go back in the place of u and write what u was, which is 7x. All right, let's look at the next one. All right, so this one is kind of weird. So I want you to look at it, think about what is the inner function and what could possibly have something to do with the derivative of the inner function. So on this one, my inner function is this the x to the 4th minus 2x. All right, the derivative of that is 4x cubed minus 2. And when we solve that for du, we get 4x cubed minus 2 dx. All right. Now, when I look at that, it's all there. So I have my 4x cubed minus 2. I have my dx. So it's it's all there. We're not going to have to do any adjustments. So we're ready to go ahead and rewrite it using U. All right, so I'm going to do e to the u there. And then all that green is just my du. Okay. So then when I do the antiderivative of that, it's just e to the u plus c. And then in the place of u, I'll go back and write what it equals, x to the fourth minus 2x. All right, so that one didn't need any adjustments, so it's nice when you can do it that way. All right, so let's look at the next one. So my inner function is going to be what's inside the square root, which is x cubed plus 1. The derivative of that is 3x, which is going to make du be 3x dx. Okay, so I'm going to adjust this. So I have the 3x. Oh, hold on. Sorry, it should be 3x squared dx. All right, now, sorry, I'm going to adjust it so I do have that 3x squared dx. So I'm going to leave this. I'm going to kind of change the order a little bit. So I already have the x squared, so I do need to multiply by the 3. And then to counteract that, I have the 1/3 on the outside. All right, so then in the place of x cubed plus 1, I'm going to put my u. And then in the place of 3x squared dx, I'm going to put du. Okay, and then I'm going to just don't have that much room. Okay, I'm going to rewrite that again because we want a power of 1/2 instead of the square root symbol. All right, then I'm ready to find my antiderivative. So I still have that 1/3 in the front. I'm going to add to my exponent, add 1 to my exponent. It's going to be 3/2. And then I'm going to divide by that 3/2. Now I think throughout the ones we've done, you guys have realized that when you divide by the 3/2, you're multiplying by the reciprocal. Right. And then that's going to be 2/9, and then u to the 3/2 plus c. And then finally, I'll go back in the place of u, and I'll put in the x cubed plus 1. I'm going to write it sideways. So I have the 2/9, and then x cubed plus 1 to the 3/2 plus c. That's your final answer. All right, so let's look at number 5. The inner function is going to be 3x squared. The derivative of that is 6x. So du should be 6x dx. All right, so I need a 6x, but I have a 3x. So I am going to have to multiply that by 2. So I'm going to rearrange it a little bit. So that's going to be a 6x dx. But to counteract that 2, I'm also going to multiply by 1/2. So now I'm ready to go ahead and replace all my x's with u's. So in the place of 3x squared, I'm going to change that to u because that is what it equals. And in the place of 6x dx, I'm going to replace that with du. All right, then I'm going to find the antiderivative. So the antiderivative of sine of u du is going to be negative cosine of u plus c. And then we'll just multiply the negative times the 1/2 and replace u with what it equals. All right, guys, that is U-substitution. Now, number 6 is one that's a little more challenging because we have a tangent here. And if we're looking at our rules for tangent, we don't have one yet. So it gives you a hint. So it tells you to rewrite the integrand in terms of sine and cosine. So one thing I hope you remember from pre-calculus is that the tangent of x is equal to the sine of x over the cosine of x. Right. Then we need to figure out which one of these is going to be the inside function, and this can be challenging on ones like this, but what we're going to do is have u be the one in the denominator, so the cosine of x, and then we're going to find the derivative of that. It's negative sine of x. All right, so I do have that sine of x in the numerator, which is where I want it. The problem is I don't have the negative, so it's okay. I can counteract that by making that sign a negative, like multiplying by -1. But we'll make sure we counteract that by putting a negative also on the outside, so that that's not a value change. It's just, it looks different. Okay, so now we will replace cosine with u, and then we're going to replace negative sine of dx with du. This also could be written as the negative integral of 1 over u du. All right, so I think we all know that that's going to be the negative natural log of the absolute value of u plus c. And then we'll go back, and in the place of u, we're going to put in what u equals, which in this case was cosine of x. All right, so your assignment over U-substitution is the topic 6.9 worksheet day 1. So it should just be the front side of your worksheet, and we'll worry about the rest of it later.